Okay, here we are at part 7 already. Yeah, part 7. We're jumping into circles. So we have to review just one really quick thing about circles, which is the kind of basic relationship amongst like the main angles of a circle. So if you take this perfectly drawn circle and choose a center, let's call it C, we immediately can form three other angles off the center. The first one, of course, is going to be our central angle. Just for our purposes, I'm going to call it angle X. We can also form something called an inscribed angle. So if we take the same 2 points that form this angle, whoa, the central angle, if we take the same 2 points and drop one down to the circumference, again, it's supposed to meet the same point, I'm going to call this angle Y. That's what we call the inscribed angle. And then there's actually a third one, a little less used, but totally still valid. We have this angle, again, using the same 2 points. Okay, iPad, now you're messing with me. I'm taking the same 2 points, but with tangents. We have this other angle, I'm going to call it Z, which is circumscribed. And so remember the relationship here is that um, y is equal to half of x, okay? And then z is equal, or I'm sorry, x plus z equals 180 degrees. And so we're able to kind of suss out the angle values if we kind of keep these basic relationships in mind, which is what we're being asked to do in the first place over here. So we're asked to kind of discern, oh, we have the circumscribed angle here, but we do have, looks like a central and inscribed. So remember, the inscribed is always going to be half the central, and you should be good. So identify the parts of, well, let's see, identify the part and the different parts, right? What? Identify the parts and the different parts of whatever circle. Let's just define some stuff. We have AO, we have OC. AO is right here. OC is right here. So my assumption is that these are talking about the radii of a circle. Radii is just plural for radius. BA and BC. Now the way they're looking, they're actually lengths. We have BA and we have BC. Those are chords. They're they're lines that go through the circle, have a beginning and end of the circumference, um, and do not go outside the circle. Here we have angle AOC. Angle AOC is going to be a central angle. BA, now if you look at the way this is marked, BA is actually talking about an arc. And so we have arc BA. If you want to be technical, it's actually a minor arc. AOC, let's just find it first. AOC. Well, it's not marked. I'm curious if that was meant to be like with an arc marking also. I think it was. No? AOC. Put a question mark there. I'm not quite sure it's meant by that one. Let's see. We have ABC, angle ABC. So we're talking about this guy right here. We're talking about an inscribed angle. Okay. I'm not quite sure precisely what's meant by AOC, so I'm just going to leave that blank for now because I don't get it. So here we're asked to find arc length and an area of a sector. Remember, these things are just part of just part of those things. So like arc length, it refers to the actual length here, the part of the circumference. Like that right there is arc length. And then the sector refers to this guy here, which is part of the overall area. So really our first job, if we're going to find the arc length or we're going to find the sector, is to figure out what portion of the area, what portion of the circumference that they really want from us. So the way we're going to do that is to first identify the central angle. So if we know that from here to here is 310 degrees and a full circle is 360 degrees, that means this angle, this central angle, has to be 50 degrees. because 310 plus 50 is 360, so that's going to be our portion that we're looking for. Now, it's advantageous to turn this into a percentage or at least a fraction right away. So the portion we're always looking for is going to be 50 degrees out of 360 degrees. A little reduction here, that'll give us 5/36 of a circle. Oh, where am I? Okay, that'll give us 5/36 of a circle. Or if we go to our handy dandy calculator, that's about 13.13, call it 13.9% of a circle. These are the two representations that are going to make the most sense for us in our problems, because it actually gives us something to multiply by. Okay? So if arc length is part of a circumference and sector is part of the area, if we're going to find either one, we need to find those two things. So let's first find circumference. Circumference is pretty straightforward. Circumference is equal to twice the radius times pi, or pi times diameter, depending what you got. In this case, we have the radius, so we have 2 times 8 times pi. So our circumference for this circle should be 16 pi. Now, if you don't like leaving your answer in terms of pi, you can go ahead and just convert it. 16 times pi is about 50.27. Okay, so before we do any other calculations on the side, I'm going to go ahead and find the area as well, because for a sector we need the area. The area of a circle is defined to be pi r squared. In this case, our radius is 8, and so the area is going to be 64 pi. And again, if you don't like seeing in those terms, let's go ahead and convert it. So 64 times pi is about 201.07. Okay, so now what we have to do is bring it back here. We have to find the arc length. We have to find the area of the sector, but we already did all the preliminary work. So the arc length which is this portion of the circumference, is going to be the same. Is going to be the percentage of circumference covered by that angle, the central angle. Excuse me. So we already established that 50 degrees is 5/36 of the angle. We know the circumference is 16 pi. So when I multiply that all together, 16 pi being circumference, 5/36 being the portion of circumference, the little part covered by 50 degrees is approximately 6.98, whatever measurement we're in, centimeters. So again, I just took the percentage, which is 5/36, times the whole circumference, which was 16 pi, and I got about 6.98 centimeters. We're going to do the same thing for the area sector. Okay, so for the sector, again, we're going to take the same 5/36, which is the percentage covered by 50 degrees, multiply it by the 64 pi, which represents the whole area, and that will approximate to about 27.93. Okay, again, not the whole area, but again, just portion covered by that 50-degree angle. So now we got to flip it around. We want the arc length and sector uh, for the non-shaded region. So we're going to do the same thing, but we're going to take a different value for percentage. So for the non-shaded region, we're going to take the 310 degrees out of 360, which again represents a portion that in this case is not shaded. Now we could have just taken like 5 over 36 and then flip that around, but this is fine. We just do the calculation for here. So 310 out of 360 is going to give you 31 out of 36. And again, if you look at our old percentage, that makes sense because if 5 over 36 is what we're covering, 31 out of 36 is what we're not covering. In the same way, we can look at that as a percentage. So if we're covering 13.9 in that shaded area, that means we're not covering 86.1 in the non-shaded region. And so we'll do this a similar calculation as we did up on, for number 2, except this will be for the non-shaded region. So let's talk arc length. Okay, so we want point. Let's keep it uniform. So we want 31 out of 36 in terms of what we're not covering. Again, the 16 pi is our actual perimeter. Okay, so if we multiply that together, we have the arc length that is not covered to be approximately 43.28. Yeah, I'll call it 29 centimeters. And again, if you compare it to your answer that we got here, these two together should be about 50.27. 43.29 plus 6.9 is pretty darn close to 50.27. And so that gives us some strength in our answer. Okay, so sector, we're going to do the same thing. So we have 31 out of 36. Our total area is 64 pi. So again, when we multiply this out, so let's see, 31 out of 36. The approximate area that's not covered by the shaded region is about 173.14 centimeters. And again, just like before, if we look at 27.93 that was covered and add to the 173, we're back at about 201. So we do have some strength in our answer here, some confidence in our answer. Okay, for each measure in circle P, we had some assumptions here. Angle WPX is 28, so let's go ahead and mark that. WPX is 28. ZPY is 38. Okay, and WZ, Z, and BZ are diameters, which means it goes to the center. And that just means that's the center of the circle. So what they want us to do is to figure out some other measurements, mainly of arcs. Now, one thing to keep in mind is that relationship of the central angle and the arc. Those are going to be the same value. So we'll use that to our advantage as we go. So the first thing we have to cover is YZ. So we want Y to Z. This is straightforward. The angle and the arc actually have the same measurement. And so this is going to be equal to 38 degrees. Now we want WX, again, another gimme. We have this arc. That's going to be 28 degrees. Now we want the angle of VPZ. So VPZ. Okay. So one thing we can look at is this being a vertical angle. So if that's 28, this one's got to be 28 degrees as well. So 28 degrees here. This is now asking for an arc. So we want the arc that starts with V, goes through W. Get out of there. Come on. Starts with V, goes through W, and ends at X. Now this is interesting because it was told in our directions that Vx is actually going to be a diameter. Diameter has 180 degrees as far as its angle, which means that this has to be 180 degrees. Now this isn't surprising because the whole circle is 360, and if Vx is a diameter, that means it covers half of it, which makes this 180 degrees. All right. Now we need x, an angle xpy. So an angle that starts at x, goes through p, ends up at y. So the way we'll attack this one is to realize that a Vx is a diameter, and that's 180 degrees. Here we have, what, 66 degrees being taken up right here, this much of it. And so this has to be the remainder of that 180. So if we take 28 and we add 38, we end up with 66. If we subtract that from 180 degrees, that means this has to be 114. Now, I know it doesn't look 114, like it looks pretty close to 90, but no one ever said this was to scale. So we can accept 114 as an answer. Now we're going to an arc. We have xy as an arc. Well, based on our last answer, if that angle is 114, its arc should be 114 as well. Now we have another arc. We have the arc that goes starts at x, goes through w, and ends up at y, which is like basically the rest of the circle that isn't currently the yellow one. Now, again, if the arc is 114, if this yellow arc is 114 and the whole circle is 360, that means the arc I just traced has to be, okay, so the arc that goes all the way around has to be 246 degrees. Last one is another arc. We want an arc, and let's make this one maybe just a bit more dramatic. We want an arc that starts at W, goes through Z, it ends at X. And so we can pull a similar trick because of the arc I didn't cover from W to X is 28. If we take 360, which is the entire arc, subtract off 28, we end up with 332, and that's what we have for a final bit of it, 332 degrees. All right. So that gives us some basic arc values. To finish this page up, we have a little problem here. So we have this new fountain outside City Hall. It's going to be the shape of a circle. The fountain is going to be segmented into 6 parts, each with an angle of about 60 degrees. If the fountain has a diameter of 34 feet, what is the area of each segment of the fountain? Okay, well, the first thing we have to do is draw this thing. So let's go ahead and draw that fountain. And so the segment into 6 parts. Okay, so there, there, there. And these are supposed to be the same value, but again, this is a drawing. And each angle has an angle of 60. So that's 60, that's 60, 60, 60, 60, 60. They also know the fountain has a diameter of 34 feet. I'm going to go ahead and chop that in half right now, and I'm going to call this 17. They should all be 17 because the diameter is 34, half of that 17, and that'll give us a radius. And what they're asking for is the area of each segment of the area of the fountain. And so you have to kind of like read between lines here and realize what they're asking for is going to be a sector. So what they're asking is to know what that sector value is. Well, we've already done a sector problem, so this should be pretty straightforward. We know a sector is a part of the area. So the very first order of business is find the area of the circle. So I know the area is going to be pi r squared. So that means this area is going to be pi times 17 squared. Which, if you don't know your squares of 17, 17 squared is 289. So the area of this particular fountain, the whole fountain, is 289 times pi. Or if you rather think of it as an approximation, which actually might work better in this case, we're looking at 907.92. Okay. So what we need now is a portion of the circle that we're actually looking for, but we're told that it's 60. So that means the percentage of the circle is going to be 60 divided by 360. Oops. Okay, it's going to be 60 divided by 360, or I can reduce that down to 1/6. Now, if you want to take it all the way down to a decimal, 1/6 is going to give you 0.17, about 0.17. So whichever way you're comfortable kind of looking at that section of the circle, take whichever version you'd like. So now we have to put all these two pieces of information together. And so if the whole area, is 289 pi, and the sector that I want is a sixth of that area, that means the area of the sector I want is, so I'm multiplying together, okay, should be 151.32, approximately. Okay. Well, let's do a little better job. Let's go put that into feet. Okay, so this is just like the sector problem above. We just want to know the percentage of the sector we need and the whole value, in this case of area. In this case is also 1/6, so if the whole area is 907, a sixth of that is about 151.32 feet. Alright guys, that is part 8. Man, this is a long review. So hopefully you're still working really hard on this. That file's no joke. Make sure you're preparing. Okay? So this is part 7. I'll see you in part 8.